Hey everyone, and welcome back to the Firefighters podcast, where we seek to develop, inspire, and motivate the world of the emergency services operator through a series of wide-ranging conversations. Now, before we go any further, just hit that rate, follow, or subscribe button on whatever platform you're listening to. It's a key performance indicator for us and helps us reach even more people. Now, here's what we've got for you today.
You know, when you're at certain jobs and you look at them and think, surely there's a better way of doing this. For most people, that thought probably passes in a few seconds. You just crack on with the job. But for today's guest, it turned into an 8, now 9-year obsession. After seeing the images of Grenfell Tower fire, Thomas asked a simple question that cuts right to the core of high-rise firefighting. Why can't we reliably get water exactly where we need it, no matter the height? I recently went out to Dubai, and they've got the Burj Khalifa there, and some of the challenges that we face in the UK with the height of our buildings, I thought, well, there's bigger problems to this all around the world, and we don't even seem to have mastered it here. So what followed for him wasn't theory. It wasn't just PowerPoint idea either. It was years of problem solving, testing, failing, refining, and ultimately building something that might genuinely change how we approach high-rise incidents. We're talking about a system that can deliver water externally to heights well beyond the traditional capabilities of aerial ladder platforms or turntable ladders. It can be deployed in minutes. It reduces the physical and logistical strain on fire crews and can open up completely new tactical options, especially when internal conditions are compromised. This one's called the Fire Spyder. Now, quick bit of context before we get into it. This episode was actually recorded back in April of 2025, nearly a year ago. We had a few technical gremlins on this one, certainly with the video, which is why, unfortunately, it's been sat on the shelf for a little while. But it's a really important idea. It's a really good innovation, and the conversation all held up, and it's too valuable not to share it. So most of these episodes are all available on full YouTube format as well. So if you prefer to see what we're talking about, most of them you can get them there, but this one is audio only. And I wanted to bring it to you because the Fire Spyder isn't just an idea anymore. It's out there, it's been tested, and it's something you can go and look at right now. If you look at the links underneath this episode, maybe you can do it whilst you're listening. And I think it's really interesting. So have a listen, take it in, and if it sparks something, check out the links and go and dive deeper. This is one of those conversations where you might find yourself thinking, why haven't we looked at this before? I'll see you on the other side. When did you first realize that there was some potential flaws in the way that we were approaching high-rise firefighting?
I saw that iconic picture of the Grenfell building, and I don't know how the human brain works, of course, but I thought, like, why is it not possible to get that water up there? I think that one of my first question mark, basically. And with inventions, you need to solve a problem. Else it is not an invention. So that's, I think, the answer to your question.
Yeah, but I suppose that also invites the fact that the mind expands like a balloon, and then it has to know that other things are an opportunity, if that makes sense. Like, people would go, yeah, okay, there's a challenge of getting water to that level. People would go, well, we've got aerial ladder platforms and turntable ladders. But even then, because of their mechanical and design limitations, they have limitations. You know, they're never going to reach. I mean, what can they get up to now? I think they can get up to, what's the highest ones can go?
6 meters is what I understand. I think the London Fire Brigade has 66 meters. But
but in floors, that's only 30 floors. It's 3 meters per floor or something. And also, you've got to think for the fact of the envelope and the angle. So it's not pure vertical. And that's when people think of these things as external, external offensive attack or even rescue resources, when really the limitations for them to be used as such is very small in comparison to some of the size of the buildings. So give us a bit of an understanding of your background and how you thought about the Fire Spyder, because it really is. I thought about it like a vending machine when I first saw it, and I thought, wow, this can literally access every compartment very specifically, very reliably, not just like hoping and pointing and guessing and fingers crossing. I had that real vending machine. But where does your background come into this, and how you thought about this sort of thing? Because most of yours came from sort of naval work and working out on ships and stuff, didn't it?
Yeah, but when I was young, it's a long time ago, I went to the Maritime Academy in the Netherlands. I studied the navigation side. I became a master mariner, especially in dredging, which is creating ports and fairways at sea. I did that in all over the world, from South America, a lot in the Middle East, Australia, Singapore. That's how I ended up in Singapore. I'm based in Singapore now, and so you in that dredging business, you
What
work
is
a lot with.
dredging? Sorry. What?
It's the
What is
removal of
dredging?
rocks from the seabed, basically, with the ship. Mm. Yeah, not many people are aware of that, but
Why?
If you sail with a ship and the water is not
What's the
not
purpose of it?
to create fairways for ships, to deepen the fairways, for example, I think that's a good example, or to create a port.
Jesus. That is
Yeah,
that's a very, very strange evolution of a requirement of humans, that we would try and shape our world to suit our needs, to the extent that we're going to drag out parts of the bottom of the ocean to make room for stuff. I mean, it seems obvious when you think about the requirements of trying to create ports and things like that, but
well,
just a hell. It kind of brings me back to that analogy of your creation. When people think of an invention, they go, "Well, what's possible here?" And you go, "I'll tell you what, we're going to move out parts of the ocean floor." And you go, "Okay, didn't realize that was an option."
you need to start somewhere, but it's not so. It's not super high technology, and I think it originates already from the Roman times. They were like dredging rivers. They would take the mud out so that the ships could go through. And nowadays we still do the same with these VLCCs, these very large container vessels and crude carriers. They become bigger and bigger, so your ports need to be deeper and wider and bigger. And I think in the Suez Canal a couple of years ago, remember when that big vessel was stuck in the Suez Canal? That's a clear example.
Yes.
You need dredging, else your ships can't go through. Yeah.
Yeah, because I imagine it just drags all the silt and the rubbish and everything, and it just starts to build up in the middle of it. And a lot of these boats, have got to travel bang down the middle. Otherwise, they're just too goddamn heavy. Anyway, so you were working in this, and you saw and trained yourself in a lot of advanced firefighting at sea. You were part of some big incidents, supporting on some salvage cases. You spoke before we came on about the Express Pearl, that container fire, sort of off Colombo, massive incident for many, many, many days, if not weeks. And then you spoke about the New Diamond. Give people an understanding about what that taught you in regard to like firefighting at sea.
Yes, firefighting at sea is. I was operations manager, so I was basically shore-based for these kind of jobs. And these jobs you just mentioned, the Express Pearl, and the other one that was during COVID, so they're extremely challenging, even to get the people there. I mean, I don't know what the time is in London for you guys to arrive. I don't even know where you work, Pete, but. For our guys to arrive, I think it was 3 or 4 days before they arrived. And
Jesus.
yeah,
So most of our turnout times across the UK is sub 10 minutes. We always commit to getting to persons within 10 minutes of a call, but it's usually significantly lower than that. Certainly somewhere like London, you'd be getting a fire engine, 5 or 6 minutes after the call.
Yeah. So to put that in perspective, in the maritime salvage, and especially during COVID, we had to charter a private jet from London, so that our Dutch salvage team, which was about 10 people, I think 12 people, they had to get to London. They go on a private jet and they fly to Sri Lanka, and then they have to go on a tugboats or whatever, and then go to the casualty, as I call it. So, but those are hectic days. Because you need to get your permissions from authorities, and again, especially during COVID. And in the meantime, your object is on fire, and I shared some pictures with you in advance, and that was not looking good.
We're working in collaboration with the Blue Light Show, a national conference and exhibition built around one thing: blue light services do better together than apart. I'm going to be there 1st and 2nd of July 2026 at the event, getting involved with those conversations and connecting with people who really care about doing the job better across the blue light sector. I'll see you there. So around this sort of time, you'd have already been thinking about the development of Fire Spyder. Like, what is that itch, that entrepreneurial, creative, inventor itch? Where does that come from for you, and sort of what made you want to apply it to something like this? Because a lot of people will see large events on the news and go, oh God, yeah, I think they should do something like this there. There's a very big chasm between thinking about something and then putting in a colossal amount of work and having some sort of passion to drive after something like this and get it to a point where you've got a working product. I saw the videos of how effectively this works. This has got to have been, I mean, what's it been now? 8 years since you first thought about it?
Yeah, I think I really that is interesting. I don't really know, but it is inspired by Grenfell, so it cannot be longer than 8 years. And I think it must have been like 5-6 years. But it's a very slow process. I mean, you have seen the system, you know how it works, but to get there, that is actually years of thinking. It's not like boom, this is the way to do it, and because you need to solve a lot of problems to solve this big one problem. Yeah, so
Mhm.
it's step by step, and I can't even really remember the process of how that goes, because there are nights that you like half asleep, half awake, and then I always tell my wife my brain is boiling, just to get clarity for myself for one subject, and the next day I'll sit down and do some calculations and some research. Like, oh, that's possible, and then you have a little
Mm.
piece of puzzle. And actually, that process is still going on because uh, it's new. I've done a proof of concept this year in Vietnam, so that's 8 years after Grenfell. Um, because people said to me, "Yeah, well, your ideas are nice, and you build a prototype, but you need to show us that it is working in real life." So I did that, and
Mm.
um, which is a big piece of the puzzle. But now I've done that, and yeah, I'm happy to say it works. It really works.
So let's sort of pull, I mean, we'll put some links in here for people to go and have a look at the videos for it anyway, but let's pull the veil back. Take us through step by step exactly what this does, what its requirements are, how it's deployed, and what problem it solves.
Okay, let me explain the basic system. From Let's start with getting water to heights, and these
Mhm.
heights that I mentioned in my explanation are arbitrary. It is possible to go higher, probably, but it becomes a bit more complicated. So let's stick to about 120 meters. Um, that's one parameter. Maximum height 120 meters. That's quite a tall building. If you take one floor 3 meters, that's a 40-story building.
Well, plus
Uh,
it's at least 50, 60 meters above the achievement of anything else we have an external firefighting media for in the UK. So
yeah,
even if it were only 80 meters, 120 meters is colossal. So yeah, let's take that as a start and set point.
yeah. Okay. So what I found out, what I realized is you need to have two anchor points at as high a point as possible, and you need to get steel wires going from your fire engine down from the floor up to the top of the building and coming down. Yeah, I was referred to the golden arcs of McDonald's.
Mm.
You have the Adam going up and then coming down, and so these wires need to be able to run freely. So you need a pulley at these anchor points. Just a simple sheaf of wires coming up and going down, and you have one on the right and one on the left.
Mhm.
So the outer wires are then connected to a winch, and the inner wires are basically connected to your fire nozzle and hose, or fire, what I call a nozzle plate. Sorry, the monitor plate.
Mhm.
One is hanging here, the one I used in Vietnam. Uh, I cannot see it myself now on video, but here's the connection
It's
for,
there. We've got it. We've got it.
you got it there. And so there's two wires going up there and there. And so if you pull the winch, the outer winch is in, the outside winch is, the plate will go up. That's pretty simple physics and mechanics. Now, you you can lift something up, but it will, of course, it cannot hold the stream, the back, what do you call it, the back
Mhm.
force. Do you have a special term for that in firefighting? The what is the back pressure, basically? So you
Yeah,
need
the back pressure, the jet reaction is what they would call it.
exactly. So you need the third wire, the third range, that's basically what I call the magical wire. This is a very important wire. If you tighten that with a constant tension system or constant tension winch, which we use a lot in the maritime industry, not only in dredging but in offshore technology and in salvage. If you pull this wire, the whole system will become under tension, right? And so you basically get a pizza pie. Um, Going to the top of the building and coming back. So that's
So take us back 1 second. So the deployment of this, there's a couple of options to how to deploy this. So you would have this turn up on a vehicle. It's got 3 winches on it. There's options of having these anchor points pre-established on a building that's a recognized risk. So you could have all of your local high-rise buildings could have these anchor points pre-installed at the top of them. So when you've assessed the risk, you go, we know this building is over X number of floors, it's above 8 floors or whatever it might be. We consider that to be a high-risk property or a high-risk high-rise building, is categorized. And in the event of that catching fire, one of your firefighting strategies, firefighting tactics, is offensive exterior via use of a Fire Spyder system. So one of the installations you would do is you would have these anchor points pre-installed at the top left, top right, front face, or you could put them on both faces of the building, I suppose. Assuming that hasn't been done, because there might have to be an agreement that is in place with the building owner because you'd be affixing something to the outside of it, although you would put it under the same categorization as a hydrant or an internal riser or a firefighting lift. It's a pre-installed firefighting resource that actually low cost, very low damage to the building, well, ultimately no damage to the building, and people wouldn't even know what it is to look at it, and it's that high up the building you wouldn't bloody see it anyway.
correct.
If they didn't have it, you could commit crews to the building, much the same as we could deploy an anchor point for a rope rescue team. We have facilities in our urban search and rescue anchor devices where you basically drill a hole, blow it out, anchor it in, test it, and then you can use that as an anchor point. And again, bearing in mind, you wouldn't be lifting a person on this anyway. This would just be for use of lifting equipment, effectively. So anchor points are in place. Turn up to the building. You have 2 drones, don't you? So these drones are part of what puts that cable system in place. What are they lifting up to start with? Because they're not actually lifting steel cables, are they? So they get deployed with, what are they lifting up?
Well, that is for the arbitrary height of about 120 meters. The drone will be your limiting factor because I thought the system, the Fire Spyder system, should be available off the shelf. All items involved should be like off the shelf. It should not be specifically have to be produced for this purpose. If you look at the biggest commercial drones now available in the market, then that will be with a payload of about 40 kg. DJI Flycard 30 or something like that can actually lift 40 kg. There's a lot of other factors that you need to factor in. Is that there could be wind and so for the 125 meters building, I decided just to use 50% of that capacity, and then you can lift up the messenger wire first.
And what is that messenger wire made up of? What is that?
That's a steel wire because I'm of the opinion that you have to reuse steel in a burning building, because if you use a fancy dynemas or other stuff, it might really up to you. And
I was going to say, because you're ultimately lifting it potentially past the fire floor, which is already broken externally anyway. So you've got flames licking out of this thing, and you don't want some line, rope, or composite plastic cable.
I have been wearing Gore-Tex for nearly 2 decades on the front line, working in hostile environments, tackling challenging incidents from firefighting to water incidents and in urban search and rescue environments. Gore-Tex have a well-earned reputation for protecting professionals in the fire and emergency services through their family of highly innovative, waterproof, breathable moisture barriers that exceeds global performance standards and are trusted worldwide. Gore-Tex, going further together.
So this is effectively a smaller steel cable that this drone is taking up and
that is what they
connecting into the anchor point.
We use that in the maritime world a lot as a messenger wire. First, you need to send, you cannot send your biggest tow wire like this. That is the diameter of the tow wire. People cannot even lift it. So you need to send a small first, and then a bigger one, and then eventually you can get the biggest one. So you can do it. So actually this comes from the maritime background as well. So you need to send the first, a very thin wire, that is capable of lifting a bigger wire with a higher, with a big diameter. And for the 125-meter building, I think you will end up with about 13 mm steel wire as the working wire. So that's
13 millimeter diameter, is that?
Yeah, steel wire. That's half inch.
It's still not massive. That's basically similar. I'd struggle to tell you exactly what our winching cables are already, but I'll bet they're not much thicker than that anyway. So it's not a very heavy cable at all. So that's going up. It's then pulling itself around onto the primary cable, which is then going to be lifting the plate and the firefighting media. We're attaching that anchor point at the base of this. If people remember back to this pizza triangle analogy, and if you're watching our video, you can see over Thomas's left shoulder. So it's got that anchoring point on the bottom of it. You then need to attach this up to firefighting media to a fire engine. What's its lifting capacity? Because if we're going to 120 meters, that's going to be at least 4 or 5, well, it's going to be 5 lengths of hose, which is bloody heavy. You have tested this. I've seen testings, and the videos will make these available to people, but that will be a reservation of people because they'll have seen, and again, I will reiterate, the drone isn't lifting the hose here. Drone isn't lifting and squirting water. This is being done by a reinforced steel cable. But people have seen the lifting capacities of things before, and they do have reservations about their ability. So just unpick for me a little bit what testing has been done on this in terms of how much delivery pressure this is able to achieve, how many hose lines are attached to it, and all that sort of. Because effectively, you're creating an external riser that you can then control through a branch. It's a fantastic design.
Thank you for that. Well, you first of all, you need to know what could be the heaviest weight of the fire hose, and especially the water. So that's when the hose is filled and at the top of the building. So let's say that's a 125 meter. So your hose and the water involved and the equipment, according to my calculations, it will be about 800 kg, maybe 900 kg.
Wow.
But these wires they can lift somewhere like 3,000-4,000 kg. I don't have the figures ready here with me, but the wires can lift it, the winches can lift it safely. Of course, it's very important that it's safely, and the system is redundant as well because you have 2 anchor points, and you can only use 1 anchor point for your calculations. You cannot say, I divide the weight over 2, because if wire it breaks or something, the whole thing comes down. That's certainly not something you want. It has to be safe for the firefighters. That's the most important thing. So what I thought of how you would tactically use a system is that you lift the hose when it's empty, so it's light, right? And when you have a capacity of let's say 3,000 kg, you lift up 3,000 kg, you can bring the hose that is actually used for the exterior attack. You can add to this place. You can get an improvised standpipe, empty. You can lift that up, and you can lift your air bottles, your hose packs that you use for the interior attacks. Everything can go up in one go. You first deliver your improvised standpipe at the 1 or 2 floors below. You through a window or something like that, or about. That includes your bottles and your hose packs, because these tall buildings, they put an enormous strain on firefighters, especially if they have to use the stairs. All right. So the Fire Spyder, which I sometimes refer to as the Swiss Army knife of high-rise firefighting, from a tactical response, you should bring up these 3 things in one go. So once you set up your system, you rigged your McDonald's golden arches, then you go up with your fire attack hose, your improvised standpipe, and your emergency equipment. Right. So you hand over your improvised standpipe, your air bottles, and everything, and then you go up with your attack hose, you can start your exterior attack, while the team 1 or 2 floors below the fire floor can prepare for their attack. So that is how I envisage the use of the system in its most basic form. One of the advantages of doing that is that you keep your stairwell intact. Sorry, which is important. So you have ample time to start your attack. That lifting process, to give the listeners an idea, with off-the-shelf equipment, would easily be 40 meters per minute going up. So it's not completely true because there's some angles, but you can reach the top of the building within 2.5 minutes. I mean, I think that's very fast. If you have
damn sight faster than carrying any equipment upstairs.
Yeah, if you make your range 60 meters per minute, which is definitely available, you are up there in 2 minutes. Right.
So you ran some testing on this, wasn't it? So I think you ran some comparisons against standard firefighting operations trying to get water to the floor. I think you ran these in a 125 meter buildings. Was it? Just unfold this as a comparison for me, because the ability for speed of attack with this is really one of the most interesting factors, I think, for me.
Yeah, no, I did not do a test in 125 minutes. It's extremely difficult to in Singapore to permission use such a building. Nobody wants to walk in this building. So I went to Vietnam, the fire academy in Ho Chi Minh, and they have a small high-rise firefighting practice tower, and that tower is 23 meters. But of course, I was limited in finances and everything, so I used like hobby drones. I used the Dyneema ropes because these hobby drones, they could not lift even a 3 millimeter steel cable. So you all are limited, but that doesn't really matter. I mean, it is about proving the concept, and that's on the video, which you can easily see. Now, Pete, I want to go back to the size of the building, because just now we spoke about drones and 125 meters, which is really tall buildings. But you can deploy the Fire Spyder without drones as well. But the buildings are not as tall. If you picture a 70-meter building, which is 20 floors and a bit, 2 maybe, you can be a lot faster if you bring your pulley up if the firemen bring up the pulleys with the steel wires and simply throw them down, cast them down, right? So your steel wire can be lighter because you don't need to your hose weight will be less because the building is less tall. So you have a bit of a leverage in the size of your wire. So I've calculated you end up about 25 kg per fireman carrying that wire up, and if you go by elevator, is
well within your manual handling regs there. So
yeah, and then once you reach the roof, and you don't even need to reach the roof, you can use it from out of a window. Uh, at least if there's a concrete floor, you can install your anchor as you described previously. You drill and you have your anchor point, which is very strong nowadays. I did
Mhm.
actually this one today, and I had it secured in 30 seconds. Uh, so drill,
Christ.
anchor in, and you tighten the wrench, and you're done. So back to a 70-meter tall building, which is actually the Grenfell size. You will be able to get exterior water on the fire within about 8 minutes from
Yeah.
arrival, provided you have the access, of course, to the roof. That is, or to other floors. That's of course very important. There is another advantage of the system. If there's adjacent buildings, tall buildings, you can use adjacent buildings as well, which are not on fire likely. So you rig up the system to the buildings next to it. And I live in Singapore. There's one tall building next to another tall building. So and there the elevators are working for sure.
So that's suggesting you'll be able to get enough throw through the branch to even fight it from 6 or 7 meters. Effectively, look, you'd be putting the firefighter media up against the building across the street. Obviously, it'd still be facing the one that's on fire, but it would
Adjacent.
require you to get enough pressure through the line. I suppose, to be fair, I'm saying that as though it's a challenge, but you could very, very easily stand across the street. It's stupid even as I repeat it to myself, actually. Standing across the street with a branch, I'm easily going to achieve a throw of 10 meters to easily penetrate into a building where fire's broken through the window. So, no, yeah, absolutely. I hadn't thought about that, actually. Because people will have a reservation. One reservation and challenge coming back in the mind of the listener will be committing people above the fire. Some people, some services around the world, certainly in the UK, might be reluctant to commit firefighters to the rooftop of a building where there's a fire already broken through 7 or 8 or 10 floors beneath. But like you say, you could commit people into a building across the street and then firefight from that position.
Instant will be better. Yeah, I'm
Mm.
aware that there's a reluctancy in going above the fire floor. That I think it depends on where you are.
It's very much a UK thing.
Yeah, I don't know. It's in Singapore as well.
Okay.
But yeah, contrary. Well, you can say that your first role as a firefighter is to rescue people, right? So you will, if there's people there, you guys will go there, right?
We'll take some risk. Yeah, save life.
And
So
I'm not a
sorry, go
firefighter.
on.
If you are early,
Mm.
if you are dispatched on time and you arrive very early, and you can maintain your stairwell integrity, and you have a lift in operation, in my opinion, whatever that is, it could be an acceptable risk. But the risk needs to be managed. I fully agree. Yeah.
So what challenges or interest or excitement, because you recently presented this over at FDIC, you had your proof of concept. I believe you went over and did a talk there. What was some of the feedback that you got from some of the people in attendance? It is beyond a privilege to be able to bring the Firefighters podcast to you, and we are so grateful for every single person that supports, listens, shares, and follows our journey. And to help us keep doing it, create more, reach more guests internationally, and make the podcast sustainable, we're asking for you to help. And to do this, we've set up a Patreon page. By joining our Patreon community, you will get access to every single full episode archive we have ever made. Now, hundreds and hundreds of key documents that we've got in there on fire behavior, firefighter health, cancer risks, instant debriefs, and so much more. So if you feel like you want to join the Patreon crew and help us make this possible, head to patreon.com/TFFPC or check the link in any episode podcast notes.
No, I did not do a public presentation. I basically pitched the ideas with the experts in the field, like one-on-ones, because I'm just starting out, Pete, so I have to tread a bit carefully. I'm not a firefighter, so I decided to take it slowly and to talk to people and get their understanding. And like what you just mentioned, the going above the fire floor, that's mentioned. while there were fire chiefs talking there and said like, no, you have to go up as soon as possible with the lift, with the elevator when it's still working, because the speed is of the essence. So I learned a lot there. Generally, the feedback I got was very positive. People are interested. Of course, people like to see innovation, which this is definitely is an innovation. But people also, I don't know what is the right word. They will never tell you like, wow, this is it. I mean, now we solved the issue. I mean,
Yeah.
it needs time to mature in their head. They need to get used to the idea, and then
And also, you've got to see it as well. It was only when I had a look at the videos, and again, we'll share the videos in the links underneath this if people want to go and have a look. That's the penny drop moment where you go, oh, yeah, I get it now. It really is one of those things. You'll have to see it once and you go, that makes sense. 100%.
Thanks for that. Yeah, and that was what the people there said as well. It definitely makes sense and it has potential. So I'm aware Rome wasn't built in one day, and so is the Fire Spyder not. And
yeah,
going to that FDIC was a very useful thing for me to do. I know who the big guys are now in the industry. I'm in touch with them, and they were positive. And let's see if we can get some collaboration from there. Because
awesome. I think it's a fantastic product, mate. I think it's a really, really fantastic design. We've had a couple of chats even before you went over to Vietnam, and you were, trying to get warmed up to get that proof of concept. Fantastic to see the videos from that. People can see the live demonstrations of it as well. If people do want to learn a little bit more information about it, I think we're going to put a link to your LinkedIn account anyway. But what opportunities will people have to either, is it a purchasable product they can actually get their hands on now, or what's the future for this?
Yeah, I really don't know, Pete. What I would like to see is that professional guys like yourself or whoever will professionally look at the system and give it a try somewhere. Somebody will, and then take it from there. And as I said, all the equipment is off the shelf. It is not rocket science at all, but it is very fast and it's very useful for firefighters in these very, very challenging circumstances. If you're more than 2-3 floors high, because I didn't mention it, but the system also works for lower floors. I mean, even within ladder reach, you can deploy the system as well. I personally think that the system is cheaper than what do you call that, a ladder engine.
Significantly. I think it was some obscene number in the many tens of millions that was spent on some of the aero ladder platforms and turntable ladders just in the UK Fire and Rescue Service alone. We're talking tens of millions. Now, again, these do have, people will say they've got not subsurface, but they've got sub-level rescue capabilities that can arch over collapsed buildings. So yes, they will still offer some solutions that, say, the Fire Spyder could not facilitate. But what are the core elements that is marketed under these aero ladder platforms, turntable ladders, is for high-rise, external firefighting. And I think this is a significantly cheaper option. Doesn't require putting firefighters at the same level of risk. You're not deploying a person. I think it doesn't have the same level of limitations because, again, it's almost an equal fight up until about 60 meters, and then the usability of a lot of those appliances. Also, you can't put them around a lot of buildings. There's a lot of buildings where turntable ladders and aero ladder platforms simply can't deploy. The footprint that they require to be able to pitch in just doesn't exist in a lot of these cities where the streets are very narrow. And equally, the weight of those vehicles is they're very, very heavy. You can't park them on certain things where there's been any underground work or there's a weight limitation on the floor or anything like that. So I think it's a fantastic design, mate. Really, really excited to have you come on and talk about it. If people want to learn some more information, we'll put some links underneath here. I know it is nearly 1 a.m. where you are, so I want to be respectful of your time. But is there any final thoughts?
I'm enjoying the Pete, but yeah, I want to add a little bit to the cost. I have not made like a financial overview what it costs, but the main cost for like the 125-meter building is these drones. They are very expensive. They're I think easily $60,000 US dollars each. You'll need two, and maybe you'll need a backup one as well. And you need the drone pilot. So that is quite expensive, but well, you get something in return because you can attack buildings of 125 meters.
And this isn't the only use you could have for those drones.
No, you can
drones used in missing persons, used in wildfires, used in getting greater situational awareness of any fire scene. To be honest with you, drones and their usability in the first responder sector is growing significantly. So you wouldn't be buying it as a standalone product just for this anyway.
Yeah, and then for the 70-meter building, you basically end up with 3 winches because this plate here behind me, that is not expensive. It's not a professional what a professional plate would look like, but that is not expensive. But these winches are within 25,000, 30,000 US dollars each, and then you can even you could even lift personnel with it and use it as a medevac because that's in the reverse system as well. If your rating is correct, for lifting people, you need a safety factor of at least 10. So if your system is 3,000 kg with your anchor points, you can use 300 kg for a medevac. Yeah. So injured firefighters, you can come down very easily and very fast. I mean, you don't need to carry down the stairs, right? So there's another
Absolutely.
thing.
As a medevac option, fantastic. Scary as hell, getting lowered down on that, no doubt, but it's a solution nonetheless. And like you say, you strap people in. We lower people down on these things anyway. There's basket stretchers that get carried underneath aero-ladder platforms as another option.
And another addition, Pete, is that you were mentioning the ladder, and a ladder engine basically only touches one point of the facade of the building, and if it's the highest point, if you turn to the left or right, you go away from the facade, right? So you have very limited facade coverage. Now, I mentioned it at the start. The magic wire is the one here below. That gives you 100% facade coverage of the whole building, because if you reroute that to the bottom corner via pulley of the building to the bottom left or to the bottom right, and you can reroute that via a sheath connected to the fire engine, the pizza pie comes either from the right or from the left. You see, you got that? Or you enter, so you have the whole full facade coverage. Well, you cannot reach the 125 meters because of the forces involved, so that will be a bit lower. But in that case, you can readjust the nozzle. You point it 45 degrees upwards, and you nicely attack the ceiling as well. Right? That is the way to do it. Yeah. So a lot of options.
100%, mate.
You can put cameras on top. You can put your infrared camera, so you know if the fire is spreading left, right, bottom.
Mate, I think you're just starting to scratch the surface of the possibilities of what can be done with this. But it's fantastic to see that you now have a working prototype for it, because I've never spent that long developing anything, and the mental resilience and perseverance it must take in doing something like that. And I know it's taking you all around the world in speaking with people, and the journey's not over. Now is ironically where the hard work, I suppose, starts.
The point is, when you start something like this, you can't stop anymore. It's impossible, because you learn new things, and I learn a lot from the experts in FDIC. I have the books that you're probably familiar with. So there's these ones. I read them. I make notes, because it's not my. They both even signed the book, so that's fantastic.
Nice.
So you every day you get new information like, hey, is this possible? No, that's not, but this is possible. So yeah, I think there's very much potential. But I'm
Yeah,
biased.
but I'm just glad to hear it's something that actually works. Like, because with respect, you probably know passionate inventors who have just so doggedly attached to, a vision of something that they have. And when other people see it, they just go, I don't think that's going to work, Tom. Whereas this is something that has genuine application. There isn't something that's offering this level of versatility, and it is a growing, genuine need. It's not like you're inventing something that helps alarm clocks work better. And well, that's great. Who's got an alarm clock anymore, Thomas? Do you know what I mean? Whereas this is actually a growing risk that we're struggling to find an answer for. And the current answers that we do have for it are multiple tens of millions of pounds solutions. They don't last forever. So I think this is something that can either be utilized, well, obviously will be utilized by the fire and rescue services, but is a solution that fire and rescue services could choose to purchase themselves, or building managers could install them, could have them purchased as something for the fire and rescue service to utilize if they turn out to their builders. Because, like you say, the storage of the elements that this would require, it's not the size of an enormous vehicle. These are the supporting elements that are required for this.
You're absolutely right. We have been talking more or less, you as a professional firefighter, we looked at it from a professional point of view, but there's a lot of countries, third world countries, who cannot afford ladders, and they could set up a very basic system like this. It's not so difficult. You can tie 2 ropes to a nozzle and pull it up alongside the facade
100%.
of a building at 6 stories, and then you can attack your fire. And there's a lot of fires in countries like Pakistan, Bangladesh that we don't even hear of. But you can use the system. You could use the system there. It's very easy. If I lived in a high rise in whatever country with not such a good regulations, I would make that system myself. I could have it ready within a week. Yeah.
Absolutely, mate. I think there's so much room for this. I think there's loads of application for it. Look, I want to be respectful of your time, but thanks for coming on. I really do appreciate it. And I look forward to touching base maybe in 6 or 12 months' time to see what interest you've had on it and see how things have evolved as then.
Yeah, I would say thanks, Pete. It was really nice talking to you. And spread the word. Share it with your colleagues. And my email address is on the website. You have my contact details. You can be free to share it with anyone that is interested. Positive feedback as well. Negative feedback is welcome, because then I have another challenge to solve. Anything is possible.
Well, that's it for today, folks. Hope you took a lot away from that episode. We started the Firefighters podcast to develop, inspire, connect, motivate, represent, and most importantly, celebrate the world of incredible emergency services operators and the wider sector through this series of wide-ranging conversations. We really love creating this podcast and bringing it to so many people. Did you know you can also find these on YouTube? We do a lot of video podcasts now. You can head over to our YouTube page and follow, subscribe there. And as a final ask from us, whatever platform you're on, please rate the podcast. It really helps us as a key performance indicator to reach more and more people. I've been your host, Pete Wakefield. This has been the Firefighters Podcast. And wherever you are in the world, please stay safe, be happy, and where possible, please remember and support your firefighters and first responders. I'll see you next time.